review, we're going to look at 1a. We know that this is an absolute value function. I have the graph already. I went to desmos.com. I like doing that. It's nice and neat. Down here, if I rewrite this, I see that the quadratic function in standard form has a leading coefficient -2, which means it's going to be an upside down parabola. Let's go down and look at the images and state the domain and range. So for the first one, we know, by the way, that these are arrows. So for the first one, the domain, the x values start at where? We know this can be some kind of infinity. The x values, negative, positive, -2 something, -3 something. The x values start coming from negative infinity because as I head over here, they head towards infinity. So the x values start from negative infinity, and then the x values keep going for something 5, something 6, something 9, something 10, something. So the x values, as we continue this way, approach positive infinity. Same thing over here. Let's look at 1b. So my x values, -10 something, right? -1,000 something. Over here, the x values keep creeping towards negative infinity. And over here, 4, something, 5, something, the x values keep getting larger, so they approach positive infinity, domain x values. Now let's look at the range, our y values. We look from smallest to largest, so we go from bottom up, and anywhere where we start touching the graph, that's part of our range. So no, 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 bam. I start touching my graph at a y value of 0. So we're going to say 0, comma, we keep going up and up and up. We are always going to touch a y value, so we say infinity. Over here, our range, we are always going to touch a y value, right? We're always going to touch, always going to touch, always going to touch, until bam, up here, and that y value is 4.5. So we'll say negative infinity, because we're touching these really low y values, and we stop at 4.5. Let's look at our next problem, x and y intercepts. So x-intercepts are where we touch the x-axis, and y-intercepts are where we touch the y-axis. If we put this equation in Desmos, and in Desmos we write y equals 4 minus x, we do the caret to raise to the second power. We have this graph over here. So we have an x-intercept here and here at -2, right, and at +2. So our x-intercepts, we're going to say -2 and 2, which we can write as -2, 0 for an x-intercept, and 2, 0. Then we look for our y-intercept. We touch the y-axis, right? This is the y-axis at 4. So our y-intercept is 4, which can be written as 0, 4. Let's go on to the next page. So we're first asked to find where this equation, y equals 2x plus 10, is positive and negative. Positive means above the x-axis, and negative means below the x-axis. And again, we're only going to refer to x values for positive, negative, and in a minute, increasing and decreasing. So positive, where are we above? We're above in this region. And that's our positive interval. And then we're below, we're talking about the whole graph, so below here, so this is negative interval that we're going to look at. So we look at, doesn't matter which we do first, so if we look to see the interval where our function is negative, we see that the graph is below the x-axis here. So we're going to look at x values. We know that our x values start negative infinity, right? So we say negative infinity, right? Because -8 something, -9 something, -1,000 something. So they keep heading towards infinity, x values. The x values keep going till they stop at, this is -5. We care about our x values right now, parentheses. Now we're looking at the other interval where the graph's positive, where it's above the x-axis. So it starts being above the x-axis at a x value of -5, comma, our x values keep getting larger and larger, right? -3, something, -1, something, -10, something, -1,000, something. They keep getting larger, so we say -5, comma, positive infinity. Let's look at example number 4. Excuse me. So where is the graph increasing and decreasing? Increasing is talking about rising. And again, we're only going to look at the x values. Decreasing refers to where the graph is falling. Falling. So this first equation, again, is a parabola, right, that opens upward. We see that this is a line. The slope is -2, so we know it's falling. So 4b, here's the line, it's falling. Oh, parabola up here, so I need to fix this. This is a line. I typed it in Desmos incorrectly. So for the first one, I'm going to go down here and show where they're both rising and falling. I need to draw this parabola. So I know that I have this point at 2, -8. Wait until it stops moving. Okay, so 2, -8. My screen keeps moving. 2, -8. Oh. 2, -8 is my vertex. 0. 4. That's a 0. Okay, if you go to Desmos, you'll see this. And you have to click on points to see the ordered pairs, okay? So I would click down here, the vertex, to see that ordered pair. It's a critical point. Max and mins, and if you have a vertex, you click on those. So let's see where our graph is increasing and decreasing. Our graph is increasing and decreasing. So our graph is increasing over here, right? Increasing is where it rises. So this is where it increases. We look only at the x values. So we start rising at an x value of 2. We have to look at the ordered pair. We keep rising, 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 and our x values head towards positive infinity. Make fake points if you're not sure, like 10 comma something, 1,000 comma something. You see the graph and your x values are getting bigger. They head towards infinity. They don't stop. We're decreasing right in here, right? You look from left to right. My x values, as I keep plotting points, we say my x value is -infinity, comma, my x values stop at 2. We're talking about decreasing, falling. Let's look over at the line. So for the line, we'll do decrease first. If I look from left to right, I start falling, 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 falling. Oh, I keep falling. So my x values, if I plot points over here, -3, something, -5, something, -1,000, something. I always touch the graph, so we say -infinity for my x values. And as I keep falling, they head towards positive infinity. X values is what I'm referring to. 2 comma something, I touch the graph. 1,000 comma something, I touch the graph. 1,000,000 comma something. X values go from negative to infinity. Increasing or rising. This graph, as I look left to right, just falls. It just keeps falling. It never goes up and rises, so we don't have any increasing interval. Okay, then lastly, we're going to look at average rate of change over an interval. So average rate of change, first of all, is formula for slope. y2 minus y1 over x2 minus x1. Let's say the problem says what if it says find, let's say find, so what I want you to do. Find the average rate of change of this function over the interval, and it will say this. Now, I know for average rate of change, I need slope. I need 2 points. This isn't 2 points. That should be a reminder. Oh yeah, they want me to plug in -2 to get 1 point, and they want me to plug in 3. We say plug into the function to get another point. So if I plug in -2, here's my equation. You plug that value in wherever you see an x. And we simplify. So absolute value of -2 is 2, and 2 plus 2 is 4. So when I plug in -2, my output's 4. That's my point. Then if I plug in 3, absolute value of 3 is 3, and 3 plus 2 is 5. This is my other point. So I'll label them. Say the top one is x1, y1, right? X, y. And we'll say that the bottom one is x2, y2. If I go and use my formula for slope, I can find my average rate of change over that interval. So y2, right? y2 minus y1, so that's 4, over x2, which is 3, minus x1, which is -2. Be careful, notice these double negatives. The formula says x2 minus whatever the number is for x1. x2 minus x1. So sometimes you'll have that double negative. This double negative means positive. So in the numerator we have 5 minus 4, which is 1, and in the denominator we have 3 plus 2, which is 5. So our average rate of change in this interval is 1/5.